So we are now going to be solving an equation. This is example number 6 that we're working on now. First things first, you've got the 4 steps there that are in your workbook. You'll note that the first one says, look to perform the opposite operation. So I don't like the word opposite, really. There's a few technical reasons for that, but it's mainly because I'm a nerd and I just don't like it. I like to refer to it, and I will continue to refer to it as inverse operations. So what you're basically talking about is what thing undoes the other. So if you're adding something, the operation that undoes that is subtraction. So 5 plus 2 is 7, 7 minus 2 is 5. So it's the operation that gets you back where you started. With multiplication, the inverse operation is division. Okay, so that's what we're going to be doing. And in maths, pretty much everything has an inverse. When you square something, you can square root it to undo it. So they are inverse operations, squaring and square rooting, or cubing and cube rooting. And there is also other inverse operations that we deal with, but you don't have to worry about that right now. So what we're going to do is they say to then add or subtract the same number to both sides of the equation, then multiply or divide. Look, that's correct. When we do 2-step or 3-step equations, we'll talk about that. But mainly, we work our way from furthest away from our pronumeral to closest to the pronumeral. I'll explain that as we go along. All right, so let's have a look. Example 6. We have solving a 2-step linear equation. So here's the equation. 3x plus 5 equals minus 2. So whenever you're doing anything like this, it doesn't matter how complicated this actual expression or equation looks. You've got to think, what am I trying to work out? What is my last line going to be? What does the person who's looking at this and saying, hey, they did a good job, or they didn't really understand, what are they looking for? In this particular case, we're looking for our end game is x equals. That's it. Or, to be honest, you could write equals x. It doesn't matter which side it's on, okay? But we're looking for x equals. So all you are trying to do is get to that point. And so you got to think, okay, how do I get there from here? What do I have to do? Well, what have they done to x? At the moment, they've got 3 times x, and then they've added 5. So we have to undo each one of those steps. So the first one we're going to do is we've got 3x plus 5 equals minus 2. The first thing we're going to do is we're going to get rid of this plus 5. Okay? So when you are first starting out of this, or if you are not confident with these, or if you are having problems with these, I would always recommend doing this step that I'm doing. Okay, so I'm actually going to change colors. I'm going to get rid of that. I'm going to write that in black. So here is my working out, as though you guys were doing it in your lovely little black pens that you all use. You don't use red pen because red pen is evil, remember? So I, however, am going to use red pen, and this is a situation where red or blue or green pen would work. I'm going to do it to write down what my step is, what my process is, what my inverse operation is. So in this case, I've got 3x plus 5 equals minus 2. So you notice that the plus 5 is further away from the x than the 3 is. So let's get rid of that. How do I undo, or how do I get rid of plus 5? Because I want x on its own. The way I do it is I subtract 5. Now, because we're mathematicians, we are fair, we are equitable, and we like things to be balanced. So if I do it to one side, I have to do it to the other side. This is why they're called equations, because they are equal. That's why there's an equal sign in there. It's not an expression anymore. It's actually an equation. So we subtract 5 from both sides. Now, when I do that, what actually happens is that minus 5 and that plus 5 will cancel each other out, because 5 minus 5 is 0. And that's excellent. So we've done that. Now I've got to do the other side. So all I'm left with on the left is 3x, because the plus 5 has disappeared. Now I have minus 2 minus 5. So I'm at minus 2. I have to subtract another 5. So I'm going to end up at minus 7. If you're not confident with that, if you're looking at that going, hang on, what the hell did he just do? Picture a number line. Okay, so if I have a number line and I have 0 up here, minus 1, and I would have 1 up there, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, so if I had a number line like that, I am starting at minus 2. Here I am, boom, starting there at minus 2. I should have done the numbers underneath, but you get the point. And now I am subtracting another 5. So the actual thing that I'm doing here is minus 2 minus 5. And so I have to start at number 2 and then go back 1, 2, 3, 4, 5 spots. So I end up at minus 7. This is not a case of where two negatives make a positive, okay? Because the minus 2 minus another 5 are two separate numbers, okay? So we're starting at minus 2, we're subtracting another 5, we end up at minus 7. All right, that was one step. That is our step 1. We are now about to do step 2. Our second step in this particular case, we have 3x equals minus 7. 3x means 3 times x. So what is the inverse of multiplication? It is division. So we're going to divide by 3. Now, if we divide by 3 on this side, we are fair, we are balanced, we are equitable, we are mindful, we are demure. Sorry about that. We divide by 3 on both sides. Okay. Now, when we do that, 3 divided by 3, those sort of cancel out and leave us with a 1. Now, we never write the 1 in front of the pronumeral, so we're just going to have x. We've got an x left. And we're going to have minus 7 divided by 3. Now, you will be tempted here to put this in a calculator. Please don't. You don't need to. When we have improper fractions, a lot of the time we will just leave them as improper fractions. However, in this particular case, we could also write this as a mixed numeral. 3 goes into minus 7 minus 2 times with 1/3 left over. So that is our final answer. X equals minus 2 and 1/3. You'll notice it still matches our desire to have x equals something. So we got what we wanted there. And that was a 2-step equation. Hopefully that will make sense. If not, give it another go. Try it with a different question in one of the examples or in the exercise, and you should be fine.